What is going on, YouTube? I hope all is well. Obviously, we are moving along here with this project. You'll notice that I have all the parts kind of strewn about that are going to go upon this turret board here. I did take some liberties and off camera do some work. I pressed in that last turret that I was missing, and you'll see here that I've ran some wires. I did that to save on time. Obviously, I don't think you really need to see me bending and, cutting off the ends of wires and stuff like that. So I'll show you real quick how I did that in a moment. First, let's go over a couple things you're going to need. First of all, you're going to need your beer of choice. I like the Foster's green stuff. Good stuff. Got to get yourself the oil can. Come on. All right. If you're a whiskey guy, that's great too. I'm a good fan of Makers or Jack Daniels. Whatever floats your boat. I would say this is probably a 2 to 3 beer task right here, what we're about to embark upon. Other tools that you're going to need. Nice pair of wire cutters, or strippers, I should say. Gotta get them strippers, come on. This isn't the most expensive pair. It's a pair of Pittsburgh. I replace them often. These work pretty well. This isn't their best stuff, but I like this one. I don't have to think too much about it, and they do the job. You'll need a pair of needle nose. You don't have to go too large with them, but obviously small would work too. These are mediums, so pair of needle nose. You're going to want to get the flush cut wire cutters. These are great. They're spring loaded, and you can kind of see they got this little flush cut side there. I like these. They're nice and sharp. They're great for cutting wires. Definitely want to pick one of those up. You're going to want to get yourself, it doesn't have to be this particular one, but a small screwdriver like this. I guess they call them precision screwdrivers. This one, has a, exchangeable tip or whatever you want to call it, but I like having it on this end to kind of help finagle wires, or you can use it to kind of help hold things down while you're soldering. So get yourself one of those. You're going to want to have one of these guys laying around. This is obviously just the cap to a laundry detergent bottle. That's great, so you can strip your wires into it, and when you cut leads off of these things, you can chop them off into that. Other things, obviously, that you're going to need are a soldering iron or station. I got this station. It's a Yihua. Yeah, I guess that's what it is. I don't know. It's Yihua. It's an Amazon special. I think it's like 50, 60 bucks. I'm actually quite impressed with it. It's comfortable. The temperature seems to be pretty accurate. I haven't really taken the time to calibrate it or nothing like that, but when it says 725, I tend to believe it. It feels about right. It maintains temperature well. In terms of all the different stations I've had and whatnot, this one's really hard to beat for the price. Get yourself, don't cheap out on the wire. Get yourself the good stuff. This is some Kester brand. This is a 1 pound spool of their, what is it? Where's the part number on it? I don't know what, it's their basic shit, but it is the leaded soldering wire. You do want to get the leaded stuff. Do not go with the unleaded soldering wire. Doesn't work very well in the long run. This is the good stuff. So get the leaded Kester soldering, rosin core wire. You're going to want to get yourself some flux. Paste flux is fine. There's obviously gels. There's also the fluid stuff as well. Whatever choice of flux you want, go ahead and get that. You're going to wish you had it. It's great for setting up the turrets to be able to solder much more easily. Aside from that, I guess we're ready to roll into kind of the wiring and all that. Obviously, I mentioned that I had gone through and already done this. There are a couple different ways you can do this. Oh, no, there's one thing I missed. Hold on, it's sitting on it right now. So let's move this over here. Get yourself a couple pieces of scrap wood, or if you've got some chunks of metal laying around, about this size, I don't know, 8.5 by 3 or something like that. That's great. You're going to want them to straighten out the leads on your capacitors and stuff like that. I don't know if you can see that, but these are all pretty straight. And how that works is with the one straight side, you take your mangled up lead, set it on the thing, and then with your other piece of wood or piece of metal, you just rub this thing back and forth. Yeah, you get it. Anyway, you do that and it'll straighten out the lead for you, and that's really nice. You want to have these nice and straight. Don't be that guy. We showed you those pictures in like part 1 or 2 or something like that, where they got the freaking mangled. No, don't be that guy. get yourself some scrap or something like that you can do this, and you'll get a bunch of leads that just look all nice and clean like they should. So this also works great for when you're slamming stuff, and doing stuff where you got high heat, so you don't melt or burn your base, your workstation or whatever. So there's that. Anyway, let's talk a little bit about the wire. We haven't really gone over that part yet. The wire is, in this build, I'm doing it with 22 AWG. There is nothing wrong with that. Some people will argue, oh, you need better than that. No, heater current, all that. Do the math on it. You'll understand why. 22 AWG is it's good for 0.92 amps, which is almost an amp. An amp is about 120 watts at 120 volts. So obviously this thing there's only milliamps worth of current in most of the sections of this amp. The heater wires is the highest draw in the amp, and I think it's, oh gosh, I don't even, maybe 4 amps tops for the heater wires, and that's in an amp that's probably got 2 or 4 EL34s and like a quad or more of 12AX7s or whatnot. So you can have a bunch of tubes before you need to start worrying about going up beyond 18 gauge. Most all heater circuits, or for the heaters on the tubes, are done with 18 gauge. On this one, we could get away with 22 AWG. There's only only 4 tubes in this circuit. But in your amp, just do the math on it. Find out what the amperage draw is. You may need 20 AWG, although there's not much to be gained with it. It's just thicker. 22 is great for all the signal stuff. This is a 3-watt resistor right here, and the leads on it are roughly a 22 AWG. So obviously you can get away with that. But for the heaters, this is 18 gauge wire here. But for the heaters, I would go with caution on that. 20 AWG to 18 AWG is probably preferable. But in this case here, in this build, I know for a fact that 22 AWG will work just fine. So just things to consider. Obviously, you got different color options. I use black and red a lot. I also like white. So black, red, and white are probably the only colors I really use. You can use whatever colors you want. Some people like using greens for the heater, green and black for the heaters, or they'll use green and white for the heaters. I like using black and red for the heaters. For the rest of the wiring in the circuit, I use white. Some people like using colors for send signal out. Some people like, using a different color for signal in. All those different options. You can do whatever you like. I like keeping it simple. So for me, I only have stock of red, black, and white. So there you have it. So that takes care of most all of that. I don't think there's much else to go over. Obviously, you want to have a printout of your circuit, your layout nearby, so you can check off all the things that you have done and have completed. Real quick, let's show you kind of how I did this wiring here. So the way I do it is I get the wire and I strip off the end a little bit so I can have the bare end. I get the wire lined up where I want it to start, kind of get it shaped roughly the shape that I need it to be. And then if you can see let's see if I can do it with this guy. The edge of the turret right there is where I'll line that wire up at, and I'll try to only cut off about a turret's width of the shielding or the jacket. And then I'll run the wire up however I need to. So let's say I need to go from here to there. So I'll get out whatever I need to get out. And if you wouldn't mind, thank you. And I'll bend it how I need to bend it. And what I'll do is I'll line it up like that. And then on this side over here, I'll cut it on the back side of the turret. So that'll give me enough lead or enough wire that when I strip back the jacket or the shield, that I'll have enough of the bare wire, obviously, that I can then bend over and stuff inside of the turret hole to then solder in. And what you end up with is this. I mentioned that people can do it different ways. You can use a bus bar if you want. It's up to you. I like doing this way. It's just cleaner. You need to make sure that you do a path, if you will, because you do have to have standoffs in here. And if you don't give yourself enough of a path, you can't just go straight over the holes. If you did that, then you couldn't put the standoffs in. So be mindful of that kind of stuff. This is how I do mine. And then what I do is after I solder those in, I'll then go back with my little handy dandy tool right here and kind of poke the wires around to where I want them to, so they're nice and straight and they're flowing in the direction and areas that I want them to. So what you're going to see as we move forward is a sped up video of me doing all the soldering on this side, flipping it over, and then starting to install the actual components. I'll probably stop for a brief moment to actually show you what I do as I'm doing it, but most of this video is going to be sped up because, like I said, this is probably a 2 to 3 beer job. So this could take, I don't know, what, hour, maybe 2. Probably closer to 2 hours for most people to do. So be prepared. Don't get too drunk, though. I would highly suggest you don't get too drunk. You don't want to make mistakes. When you get too drunk, that's when mistakes start to happen. Just just think of your ex-girlfriends or something like that. Anyway, stay tuned and let's rock on. All right, here we go. Anyway, we got that. Just want to wipe off any excess residue, make sure all the electrical cleaners evaporated before we start putting any more hot iron on this thing. Yeah, we're looking pretty good. We'll go back through and make sure that we got all that really nice before we're done. It looks like everything's done pretty well here. It'll get sprayed with electrical cleaner a few more times. All right, so I already know that this capacitor here is going to go here in this position. See if I can get it to do it. Yep, there we go. All right, so what I'm looking for is our 1.5K. Sheesh. My eyes are absolutely destroyed today, so I'm sorry. I think they were 1.5K. I don't really have a light on over here that's doing good. That's a 1.5K. Alright, we'll deal with the rest later. So, so what I do, man, oh man, maybe I need more of these. I'm getting old. Older than my voice probably lends me to appear. I talk like I'm 12. I act like I'm 12. But I am actually much older than that. And my eyes, even though I don't need reading glasses or anything like that, I can only do this for a little while before they start getting pissy with me. But I've been doing this all day, kind of getting all this prepped and getting all lined up and ready for you. So, excuse me. So we want to make sure that we pay attention to the polarity with these types of capacitors here. So this is the negative side here, because we're looking at this side of the layout, right, or the board. So this is all of our negative side. So this is all of our positive side on this half of the board. And this is why I was talking about how layout's really important. On this side of the board, everything is negative, and on this side here, it's all the the positive side, if you will. We don't have like things crossing each other and going in other different directions. This is great right here. You want to try to make sure that your layout allows for you to have this type of thing going for it. You want to try to keep the high tension stuff on this side or on a side, while all the ground plane stuff stays on the other side. So just, for your design considerations when you're designing your stuff and building your stuff, you're trying to keep things, you gotta keep them separated. Hey, don't pay no mind. Anyway, so my other thing is I like to keep the values pointed up at me. I like to be able to see what's underneath there. So when I do this, I will take the leads, I'll lay it out like that, and then I'll take my needle nose. So let's kind of get this in another view here. And we're going to speed up here in a moment, so I'm just trying to show you guys what we got going on. But so obviously this is my positive side here, so we need to make sure we got this in the right orientation. I turned it around. So I'll lay the part, and I want to make sure that it's centered, and I'll use these reference points here. And for me, I'm going to lay it inside the holes. That's kind of a popular thing to do. I don't see any problem with it. So you get it lined up, and then I find that generally right around the area where the turret touches the needle nose, it's pretty close. And right in there somewhere ought to do. And then you just bend the lead down. And then you do this, I lay it on its side to make sure, because that's where it's going to go in the hole, right? And we're pretty dang close right there. I'd have to say we're about dead nuts. So then you do the same thing over here. You kind of, pulled up my thing, darn it. You get it lined up. Darn it, I moved it. Not supposed to move it. Right in there. So you kind of get a grip on it right there where it needs to be. And then when you taco it over, you get that. And you can kind of tell right away if you got it right, because it'll look about the same on each side. And then when you lay it on top, you'll see that the little things kind of line up. If you would not move, that would be so great. But you can see here how they just kind of line up right in the holes there. That's great. So then what I do is I rotate the leads, because I want this verbiage right here to be facing up. I know my lighting is horrible. My apologies. It's probably half the reason my eyes are so bad. Now what's beautiful is that once you get it kind of set in there, you can almost twist it to be where you need it to be anyway. So this is looking pretty good right here. You don't need too much sticking down on the bottom here. So you only need a little bit sticking down there. All right. So that's probably good right there. That might even be deeper than I need it to be, because that's just going to sit inside the top of the turrets there. Now I'm not going to solder these yet until I get them all into place, but as you can see here, it's just kind of setting there, and it is very well centered. Very well centered over the thing. And of course we can fine tune some of this stuff once we get it actually soldered in place. But that's pretty good right there. Now what we need to do, I think I can get rid of this thing now. It's moving around too much. So I got the hot work done now. We're not doing any more of that. So I'm going to go ahead and turn off the iron now, because most of what we're going to be doing now is actually bending the leads on these things. So let me see if my eyes can actually see for sure if this is a 1.5K. I can see that it's a 1%. I can see that it's a Dale. Oh man. That's a 680 ohm. Where did I put that little guy? Pfft, right here. Ha! Yeah, that's how bad my eyesight is right now. 1.5K. Alright, so here's our 1.5K. So same kind of difference, except for we're going to go up. And see here, we're over the top of this. I wanted to use 2 turrets so I could have them just side by side. I don't really like stacking things in turrets if I don't have to, but in this case, in order to get this space here that I wanted, I needed to do that. And to keep kind of this, you know, the spacing that I have, you know, especially to go to the components, the external components or off-board components, I had to stack these. So that's kind of just how that went. So we'll take that, we'll set it aside. And what we're going to do is the same exact thing here. We're going to take this thing, I want the value to be facing up. So that's the value there. And then we just kind of find where it's in the middle. That's pretty close right there. And I think like right in there. And right there. Yeah, we'll do that. And bend that over. And we made a nice 90. Ooh, I'm a little off. Just an ever so slight amount. It's not the end of the world. We can kind of make that work, but this is always kind of the challenge. So do you want to... How close am I? And that's really close. I'm going to run with this for now. So on this side here, same kind of deal. We're going to set that where we want it. We get that kind of lined up there. Give that a little rotation, because you want to try to bend these leads the correct direction right off the get-go, and then just give it a little bend down. So it's pretty dang close. You can kind of see there, it looks pretty good. So another way to tell is if you put it in there. We know that it's going to go in, but it doesn't look too bad. I think this will work, because this one's going to go over the top of this other guy anyway. So we need to have a little bit of play. And how that's going to work is we'll put this in here, and then this is going to go over the top, right? But we want to cut it down so that it goes almost... We don't want these to stick out the bottom of the turret. Obviously right there it's going to get stopped up anyway. So we don't need this to have a super long amount of length just in general. So we want to just cut a little bit off, but we want to leave ourselves some length. So I'm going to cut off about half of what we got. So cut off about half. And we'll see how that does. We'll see if that gives us some space here. Because what we do when we solder this, so it went all the way down on both sides. It's just touching before it gets down all the way on this side here. So not bad. I did good there, because we need to get this up a little bit anyway. So for now, what we're going to do is just check our fit. And that's going to work great. So we need to come up a little bit to leave some air in between those two. I want to leave some space. I don't know how well you can see that or not. I apologize if you can't, but they're going to sit over the top of each other like that anyway. But we want to make sure that we can put some air between them. And we also want to try, there we go. Yeah, so this is gonna work great. So these two are done. So we're gonna move on. So you're just gonna see a bunch of me doing a bunch of that kind of crap. So stay tuned. So these ones here are a little more challenging because they will sit on the turret board. That means we got to come down as well. So just keep in mind that you want to make sure that you leave a little extra length on the leads when you bend them. So we'll do this one real quick and see what I mean here. We're getting real close to the end though. Here, we're almost done. And well, I'm only about halfway through this beer. Which is this is actually 2 beers worth because this is an oil can. So that's 24 ounces of freedom right there. But I'll probably be done with that here shortly. So get this thing all centered up. Now these ones are more critical because they do have the wire or the line that comes down. Nailed it. I think we did good. So I got to cut a little more off here. Okay, so it did not take that long for me to bend all those and fit all those parts in. As you can see, even taking my time and fumbling about, it took, what, an hour and a half is how long this video's been going. So I was about right on the money, about an hour and a half. So for an inexperienced person, maybe it'll take a little longer. I've downed about a beer so far, a little over a beer, about a beer and a third. So, yeah, about 2 beers for the average person. So, in either case, you'll notice the only parts that actually stick to the board are these guys, and that's because once you bend them into place, you really can't remove them. So, we're going to pause real quick right here while I go to the bathroom, and we'll come right back. All right. So, now what we're going to do is we're going to put some solder paste on all these joints here, and we're going to go about things. You'll notice that the only one I haven't installed or cut yet was this guy here. That is the bias resistor for the output section. The reason I haven't installed that yet is I'm not too sure yet what it's going to need to be. I think it's usually around 150 ohms. Let's see. Let's see what I got here. It's between 150 to 180 ohms. It depends on how the rest of the amp is working. There's a couple different ways you can kind of tune this thing. So for now, what we're going to do is just move on. We're going to paste all this stuff up and then start loading it back up and soldering it. So I'll be back with you in a minute. Alright, so you don't have to do this. I like to do this. It's black RTV silicone. I like to silicone these 3 big ones just because they're big and they have mass and they sit directly on the board, so I want to keep them pretty well attached. These ones here, not such a big deal. I probably can put this one in. I don't really worry about that one as much, but these 2 over here for sure need to have some sort of stuff. You saw me earlier, I undid that one. It's because I need to put this guy in, and I was debating whether or not I wanted to do some silicone underneath that one or not. I'm not gonna. It doesn't need it, I don't think. Not in this position at least anyway. But so we're gonna go ahead and put this one in. Yep, there we go. Alright, happy with that. Happy enough anyway. Okay, let's get some silicone down. This is where we put rag underneath. It's gonna squish out a wee bit. We don't want that. We don't want none of that. Oh, buds. And you. Okay. This stuff's about done. Alright, let's get a little raggy. Yeah. Make sure these are going the right direction. Only get one shot. And we come back in a few minutes. Okay, everything is in now. Beautiful. Just straightening things up a little bit here and there where I see fit. So these ones here I should have done differently. I kept them on the top and bent them in. That's not what I like to do, but that came out really good though. So this capacitor, as you can see, sticks up a way bit. That's the only reason I have to use a 3-inch tall chassis, is so that way it clears it. I guess you don't have to, but it certainly makes it a little bit easier. But I may go back and change that. I don't know. I might put those underneath. I don't necessarily like that. I don't necessarily dislike that, but I've done better, I've done worse. I'm trying new things here, as you can maybe tell or not. I don't know. I guess for me, I'm trying to make the build go a little bit quicker, usually. I mean, for me, that was exactly 2 beers. That's start to finish on that project, which is running about an hour and something still. Or is it? Oh, I quit hitting the damn thing. Sorry. I can't even read the damn thing. I don't know, it's like 2 hours and some minutes, but not too bad. I mean, Average Joe, like I said, could probably do it in about 2 hours, so it doesn't take too long. So then what we'll do after all the silicone dries over here is we'll spray off any leftover residue that might have gotten in here from the like right here, all that flux. We don't want that flux in there, so we'll go and get that out of there here in a bit. But that's it. This board is stuffed, ready to go. The only thing I have to do here is put in the bias resistor, the cathode resistor for the output section, and that is kind of more of a down the road sort of thing. I don't have to do it right now, so we'll come back to that in a bit. But there you have it. That is a stuffed board right there. I'm not happy with that. We'll probably redo that. I kind of prefer it to go down to the bottom like the two resistors down there. But I mean, you can see you can do it pretty quick. You can do it pretty clean. So here we are. Take care. We'll see you in the next one.